Lead-acid batteries are mainly used in motor vehicles to provide the electrical energy necessary for the car until the alternator starts producing electric current. The battery stores electrical energy in the form of chemical energy. The battery consists of a plastic casing and battery cells. Within these cells, positive and negative plates alternate and form a comb-like structure. Each cell produces 2 volts, but by connecting multiple cells in a series, a higher voltage power source can be created. A lead-acid battery has a charge-discharge efficiency of 60 to 70%. In the lead-acid battery, there are 2 electrodes within a cell immersed in a solution of water and sulphuric acid. When the battery is fully charged, these 2 electrodes are a positively charged lead dioxide plate and a negatively charged lead plate. The electrolyte in the battery is the sulphuric acid solution. When an electric load is connected between the electrodes, electrons start flowing through the circuit, that is, the battery discharges. Charging occurs when an electric current is applied to the battery. When the battery discharges, both lead and lead dioxide react with sulphuric acid to produce lead sulfate. As more water is produced during this reaction, the sulphuric acid solution becomes diluted. This process is reversed when the battery is charged. Lead dioxide forms on the positive electrode, the cathode, and lead forms on the negative electrode, the anode. Water molecules break up and sulphuric acid is formed. Thus, the electrolyte becomes more concentrated. These processes occur during each charge cycle. When the battery discharges, the direction of the current is opposite to the direction when the battery is charging. During discharge, the lead plate, the anode, releases lead ions, and 2 electrons are formed. The lead ions react with the sulphuric acid to produce lead sulfate. When the circuit is closed, electrons start flowing from the lead plate, the anode, to the lead dioxide plate, the cathode, through an electrical load connected to the battery. During discharge, the lead dioxide on the lead dioxide plate also reacts with the sulphuric acid to form lead sulfate. During the process, the oxygen ion in the lead dioxide and the hydrogen ions in the electrolyte combine to form water. A lead-acid battery is continuously charged and discharged. When it is connected to an electrical load that requires electricity, for example, the starter in a car, current starts flowing from the battery. When no load is connected to the battery while driving, the alternator charges the battery. This process of discharge and charge means that energy can be discharged and restored again and again.